Hi folks, this is number 25 from page 227. So they're asking us to find a solution for this trigonometric equation here. And while we often like having everything to one side and the other side equaling 0 when we're solving a trigonometric equation, there's not really too much we can do here, because even if I switch this over to a tan value, I don't have the same inputs. Okay, so this is where hopefully you think of actually taking one of these to the other side of the equation. So let's say I take the tangent to the other side of the equation, and I rewrite this equation as cotangent of 4c minus pi over 4, okay, equaling negative tangent of 2c plus pi over 4. Okay, and when you have it in this format, well, this looks a lot like our correlated angle identities, okay, where we have not quite an equivalency of two trig ratios, but they're negatives of each other, and they're different trig ratios. So because the fact that these are different, it's not a tan equaling a tan, it's a cotangent equaling a tangent, that it would be one of our correlated angle identities or cofunction identities, whatever term you want to use. Okay, so question is which one do we use? So again, instead of memorizing them, I use a diagram as a guide. So I always assume that one of my angles is in the first quadrant. Okay, and in this case here, cotangent is equal to the negative of the tangent. So our second angle has to be one in which cotangent is negative. All right, so it's not going to be in the first quadrant because cotangent is positive there, but cotangent is negative in the second quadrant. So the other one of my angles that I could use, okay, would be pi over 2 plus theta. Okay, so then I go down to the third quadrant. Cotangent is positive there, so I don't want to use that angle, but it will be negative in the fourth quadrant. So the other angle that I could use would be, remember, 3 pi over 2 plus theta. All right. So again, just to remember what these look like. So as one of the examples, if I take this one here, I can say that cotangent of pi over 2 plus theta is going to be equal to the negative of the tangent in this first quadrant. Okay, and I'm going to now use this identity to relate it to the equation that I actually have. Okay, so I'm going to call this thing here my theta. So one possible scenario is that the angle on the left-hand side, so 4c minus pi over 4, is equal to pi over 2 plus theta, which is represented by this angle here. So plus 2c plus pi over 4. Okay. Now you might say, why am I putting this in brackets? I don't need to, it's an addition. Just as a reminder that if I was subtracting this angle, if it was a minus theta, I would have to put this in brackets in order to get the correct signs in front of my terms. Okay, so now I can just solve this here. So I'll take the 2c to the other side. So 4c minus 2c is just 2c. And so here, what do we have? We have pi over 2. We have a plus pi over 4. And here, bring that to the other side, another plus pi over 4. So 2c equals, well, pi over 4 plus pi over 4 is pi over 2, plus another pi over 2. Hey, that's just equal to pi. So one answer would just be pi over 2. All right? So that's one possible solution for this equation. Now I'll find a second solution using this other identity. So I'll use the identity cotangent equals 3 pi over 2 plus theta equaling minus tan of theta, and see what that produces. Okay, so for my second one here, I'm going to have my 4c minus pi over 4 equaling 3 pi over 2 plus theta, but our theta is 2c plus pi over 4. So again, I'm just adding. Okay, no issues with signs, but I'll just get used to always putting brackets around there. And now I can solve this equation. Okay, so again, bring the 2c to the other side. So here, what do we have? I'll just put everything over 4. So this is going to be 6 pi over 4. We already had a pi over 4 here. And then here, again, we're adding a pi over 4. So 2c is equal to 6, 7, 8 pi over 4 is just 2 pi. And so c is just equal to pi. Okay, and there's a second possible answer. Now, by the way, you might want to start thinking about how you might find a third answer or a fourth answer for these types of equations. Okay, so let's just check one of these answers. Okay, so I'll check this answer here because it's a little easier. So let's just see that when I put this in, the left-hand side equals the right-hand side. So left-hand side equals, and let's just get our calculator here. So let's put in pi. So what do we have? On the left-hand side, we have cotangent, which is 1 over tangent of 4 times pi minus pi over 4 minus pi over 4. Okay, and that gives us -1. So our left-hand side is -1. Okay, and then our right-hand side, okay, is negative tangent of this angle here. So our right-hand side is negative tangent of 2 times pi, and this time it's plus pi over 4. Okay, and what do we get? Lo and behold, -1. Okay. And again, I could do the same thing with the pi over 2, and I should get the left hand and right hand side being equal. So just to do a quick recap here, first thing is to realize that leaving both of these terms on the left side of the equation wasn't useful, so I brought one to the other side, and I end up with a scenario where I have two trig ratios that are negatives of each other, but they're not the same trig ratios, so that makes me think of my correlated angles, which are the ones that use pi over 2 and 3 pi over 2, and I just had to determine which ones to use. And in this case here, the fact that a cotangent is equal to a negative tangent, so I just had to figure out in what quadrants cotangent is negative, which are in the second and the fourth. So that gives me the identities to use, and then I just take my equation and I relate it to the identity. So my left hand side is equal to pi over 2 plus theta, and the angle on the right hand side is just equal to theta, and that allows me to create a nice equation to solve. Okay, that's it for this one.